Okay, Unit 8 Test Study Guide, question number 27. This is getting into independent and dependent events. 3 marbles are removed from the jar with replacement. Means that when we pull the marble out, we're going to see what color it is, but then we're going to put it back in the marble, put the marble back in the jar and draw again. Important issue, we're drawing 3 marbles from the jar. So we have to reach in 3 times. The probability of getting black all 3 times, the first time you reach in, there again, probability, favorable over total possible. There are 4 favorable, what you're looking for, 4 black marbles. I want to put that up higher because I want to reduce before I multiply. 4 out of 10 possible marbles. You'd reach in, you'd pull out the black marble, you'd put it back in, and you're back to the jar having 10 marbles in it. So when you reach in, it still will have 4 black marbles in there. So you reach in the second time, it is still 4 favorable outcomes, black marbles, out of 10 possible. You put the marble back in the jar, you reach in again, it is still 4 black marbles out of 10 possible marbles. Reduce before you multiply. All of these, both of these can be divided by 2, so this becomes 2/5. You're going to multiply the probability of each step, of each event, together to get the probability of all 3 of these happening. So it's going to be 2/5 times, both of those divide by 2, you get 2/5 again. Both of these divide by 2, again you're going to get 2/5. You multiply numerators times numerators, so 2 times 2 is 4, times 2, 8 favorable outcomes over 5 times 5 is 25, times 5 again, 125. That is the probability of getting all 3 black marbles when you reach in and with replacement. 8 out of 125. The probability of getting all red, again, there are 10 marbles here. It looks like there are only 3 of them that are red. So you reach in the first time, the probability of getting a red marble is 3 out of 10. You're going to take the marble out, you're going to put it back into the jar, and so when you reach in for the second marble, it is still 3 red marbles, favorable, out of 10 possible marbles that you could get. And again, you're going to put that back in before you reach in for a third marble, and when you reach in for the third marble, it is still the same situation. 3 favorable out of 10 possible. There's nothing that you can reduce, so just multiply numerators times numerators. 3 times 3 is 9, times 3 is 27 favorable outcomes over 10 times 10 is 100, times 10 is 1,000. 27 out of 1,000 is the chance of getting all 3 red marbles. Question 28. Again, 3 marbles are being removed, but this time it is without replacement, which means we're going to reach in and we are not going to, when we pull out what we're looking for, we're going to assume that we get what we're looking for. We're not going to put it back in the jar. So the number of marbles in the jar has changed. The first event affects the second event. This is a dependent situation where one event depends upon having done the previous event. So, reaching in to get all 3 marbles to be black, the first time you reach in, there are 4 favorable outcomes out of 10 possible outcomes. You assume you get a black marble, but you don't put it back in the jar. So when you reach in again the second time, if you took out a black marble, there are only 3 black marbles in the jar. And not only that, one marble, the marble you took out, you didn't put back in, there aren't 10 marbles anymore. There would only be 9 marbles. You reach in a third time without putting that second marble back in, there would only be 2 black marbles left, and there would be only 8 marbles in the whole jar. I might have done better if I'd crossed these off as I went to show that they were missing. Sorry. Okay, then, again, reducing before you multiply, you're going to multiply the probability of each of these together. Reduce before you multiply. 3 and 9 can both be divided by 3, so this becomes a 1, this becomes a 3. 10 and 2 can both be divided by 2. I'm going to reduce that way because I'm going to reduce the 4 with the 8. So 10 and 2 can both be divided by 2. The 2 becomes a 1. The 10 divided by 2 would become a 5. 4 and 8 can both be divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So on top I've got 1 times 1 times 1, so I've got one favorable outcome out of 5 times 3 is 15 times 2 out of 30 possible outcomes. That would be the probability of getting 3 black marbles without replacing. Okay, then the probability of getting 3 marbles and having them all be red, the first time you reach in, again, there are 3 red marbles, so favorable over total possible. And yes, you have to assume that you're starting over with the jar for this problem. You're starting with that jar to do problem 28b. So the first time you reach in, there are 3 favorable out of 10 possible. Then you keep that marble out. One of the red marbles is gone, so now there are only 2 red marbles in the jar. And because you kept that first marble out, there are only 9 marbles in the jar. Again, before you're going to reach in to get a third marble without putting back either of those first 2. Well, if those 2 are both red, there is only 1 red marble left in there now. And since we've kept 2 marbles out, there would have only been 8 marbles in the jar. So the probability of having all 3 of them come out red, we have to multiply these together. Again, reducing before you multiply is a wonderful thing. 3 and 9 can both be divided by 3. Divide 3 by 3, you get 1. Divide 9 by 3, you get 3. 10 and 2, let's reduce this way. The 2 and the 8 can both be divided by 2. This 2 divided by 2 is 1. 8 divided by 2 is 4. Why did I do it that way? Because it's really easy to multiply by 10 rather than multiplying by 5. So I wanted to leave that as a 10. So I reduced the 2 with the 8. Multiplying the numerators, 1 times 1 times 1, I would have 1 favorable outcome. On the bottom, it's easier for me to multiply 3 times 4 first. That would be 12. And then 12 times 10, there would be 120 possible outcomes. And that is your answer. 1 out of 120 to get all 3 red without replacing the marbles.